Hello, everyone. Welcome to our lecture on the trends of the periodic table. This is a continuation in terms of we're going deeper into understanding all the information that the periodic table tells us. In this case, the periodic table holds a lot of trends where basically as you go along a period and go down a group, we notice that elements act in a very specific way compared to each other. The first of these trends is their atomic radius. The atomic radius is the distance between the nucleus, the center of the nucleus of an atom, to its outer valence shell. So think of it like the radius of a circle. We measure this by getting half the distance between two nuclei that are the same atoms that are bonded together. That's because we can actually measure this distance, but measuring an atomic radius is not possible. So we measure the distance between two nuclei of the same atom bonded together. We take half that, and that's how we find the atomic radius. So the atomic radius decreases along a period. So as we go from left to right along a period, the atomic radius gets smaller. This is because each one has more protons and more valence electrons than the element that came before it. Those protons and electrons pull together, decreasing their distance from the nucleus and therefore decreasing the atomic radius. Stronger electrostatic interactions pulling together stronger and makes the radius smaller. The electrons are closer to the nucleus. The atomic radius increases along a group. So as we go down a group, the each element has a larger atomic radius. That's because going down a group, each period adds a new energy level. The electrons in that new energy level undergo something called shielding from the electrons in lower energy levels. Shielding is the reduction in electrostatic between the positive nucleus and the valence electrons on the outer shell. Basically, what's happening is the outer electrons, normally electrons are attracted to the very high positive charge of the nucleus. So that's how they're pulled together. But when you have inner shells here with electrons, those like charges, because they're both negative, repel each other. They have the repulsive charge that causes them to not get pulled as closely as if they weren't there, basically acting as a shield to these outer valence electrons. So as we get more energy levels and more of these shielding electrons, the valence electrons get farther and farther from the nucleus, which is why our atomic radius increases as we go down a group. So to recap here, as we go from left to right, the atomic radius decreases. So lithium has a larger radius than beryllium because beryllium has more electrons and more protons that hold it tightly together, and it keeps getting smaller as we go down. And then we know that the atomic radius increases as we go down because we get new energy levels and have repulsion between electrons of varying energy levels. So the smallest atomic radius out of any element is helium. And yeah, this is a recap. We will continue to learn more about trends in part 2.